Hi, Nate Mullins here, also known as Mr. Nate by some students. Anyway, I have a video tutorial for you on advanced divisibility rules. Now, it helps if you have looked at my tutorial about divisibility by 7, 8, and 11, as this assumes that you've looked at that, or you know the divisibility rules for 7, 8, and 11. They're a little bit more advanced than the traditional 2, 3, 4, 5, and so forth. So we're going to look at two important concepts when we're determining we're going to look at numbers. We did 1 through 11. We're going to look at numbers between 12 and 100, and we're going to leave some out because some of them are so advanced, but there are two important concepts here. Take a number, n, we'll call it n. If it's divisible by another number x, which is formed by two numbers a and b, if x is the least common denominator, LCD, of a and b. Well, what does that mean? Two examples here. A given number is n is divisible by 18 if it is divisible by 2 and 9, because the least common denominator between 2 and 9 is 18 itself. 3 and 6, even though they multiply together to give you 18, will not work because their LCD is 6, not 18. And that actually falls into this category down here, which we'll get to in just a minute. Our second example, a number n is divisible by 24 if it is divisible by 3 and 8, since the LCD between 3 and 8 is 24 itself. 4 and 6, even though they multiply together to give you 24, will not work because their LCD is 12, not 24. The other thing to remember is that if a number n is divisible by a certain number x, then your number n is also divisible by all of the factors of x. So an example of this would be 48. It's evenly divisible by 12, 4 times. So it is also divisible by all the factors of 12, which would be 1, 2, 3, 4, 6, and 12. And then the other factors of 48 would be 8, 16, 24, and 48. So we're going to do a brief review here. 1, we really don't have to do. It just has to be a whole number or integer to be divisible by 1 evenly. 2, any even number, ends in 0, 2, 4, 6, or 8. 3, the digits of the number have to add up to a multiple of 3. So 57, for instance, a lot of people think that's prime, but it's not because it's divisible by 3, 19 times. 5 plus 7 is 12, and 12 is indeed a multiple of 3. So 57 is divisible by 3. For 4, you only look at the last two digits, and then you take that number and divide it by 2. You half the number, in other words. And if the resulting number is even, then the original number is divisible by 4. So for instance, 76, let's say you have the number 476. The 400 doesn't really matter. You only look at the last two digits. 76, you take half of that, gives you 38. And because 38 is even, 76 is therefore divisible by 4. So you have to be able to divide it by 2 twice, in other words. 5, piece of cake, has to end in a 0 or a 5. 6 has to be divisible by 2 and 3. So in other words, look for divisibility by 3, and it also has to be even. And this brings up a point here before I go to this one. If you're looking for divisibility by an even number, and you have an odd number, you can never divide an odd number by an even number without a remainder. It's impossible mathematically, because if you multiply an even number by anything, whether it's even or odd, you're always going to get an even number. So if your number is odd, you can rule out divisibility by 2, 4, 6, 8, 10, 12, any even number. So that's one thing to remember here. Okay, 7, 8, and 11. See this tutorial if you haven't already, or unless you already know rules for 7, 8, and 11, which are a little bit more complex than some of these other ones here. And then 9, same concept as 3, except the digits of the number have to add up to a multiple of 9. So the number 378, 3 plus 7 plus 8 gives you 18, which is, of course, 9 times 2. It's a multiple of 9. 10, easy, just has to end in a 0. So now we look at the new rules, and we're kind of putting things together here. For divisibility by 12, you look for 3 and 4. 2 and 6 won't work since the LCD between 2 and 6 would be 6. So you look for divisibility by 3 and 4. An example would be 252. You look at the last, first of all, it's divisible by 3 because 2 plus 5 plus 2 is 9, which is a multiple of 3. You look at the last two digits then to check for divisibility by 4, and 52 is divisible by 4. Of course, if you play card games, you know that. 13 times 4. 14, look for divisibility by 2 and 7. So anything divisible by 7, that's also even, in other words. So 182 would be an example. Remember the divisibility, it's even, and the divisibility rule for 7 says that you break off the ones digit and double it and then subtract it from the rest of the number. So 18 and 2 would break apart into, well, 182 would break apart into 18 and 2. 2 doubled is 4, and then you subtract that from 18. So 18 minus 4 is 14, and 14 is a multiple of 7, of course. 2 times 7. For 15, you check for divisibility by 3 and 5. So the number has to end in 0 or 5, and also has to be divisible by 3. So 420, 4 plus 2 plus 0 is 6. So yes, it's divisible by 3, and it ends in a 0, so it's divisible by 5. Therefore, it's divisible by 15. 2 and 9, again, that was that example I gave you, not 3 and 6, but for 18, you look for 2 and 9, so any even multiple of 9, in other words. So looking at that number 378, that'll come up again. 3 plus 7 plus 8 gives you 18, so it is divisible by 9, but it's also an even number, so it's divisible by 2, therefore it's divisible by 18. Now 20, that's pretty easy. Has to end in a 0, and then you look at the tens digit, and the tens digit has to be 0, 2, 4, 6, or 8, so it has to be even. Also, you could check for divisibility by 4 and 5, but I think this first method is a bit easier. For 21, look at 3 and 7. 189 would be an example. If you take, first of all, 1 plus 8 plus 9 gives you 18, which is a multiple of 3. And if you take 189, break it apart into 18 and 9, you double 9, which gives you 18. 18 minus 18 is 0. And by rule, if you get 0 when you're checking divisibility by 7, it's divisible by 7. So 189 would be a multiple of 21, divisible by 21. 22, you check for 2 and 11. So 572, now remember the rule for 11 was just like 7 except a little bit easier in that you don't double the ones digit. You do the same thing. You would break 572 into 57 and 2. You take the ones digit, and instead of doubling it, you just subtract it from the rest of this number. So 57 minus 2 gives you 55, which is, of course, 5 times 11, so it's a multiple of 11. And it's even, so therefore, 572 is divisible by 22. 24, the other one I gave you in that example of, not 4 and 6, but look for divisibility by 3 and 8. 528 would be divisible by 24. Now, 8 was a little bit complicated. 28, if you divide it by 4, well, first let's look for 3. 5 plus 2 is 7, plus 8 is 15, which is a multiple of 3. Is it divisible by 8? Now, if you remember that sort of table I had in that other video tutorial, 28 is divisible by 4, so it's a candidate, and you look at the last 3 digits. 28 is not actually divisible by 8 itself. but since it's divisible by 4 and this hundreds digit is odd, that makes the number divisible by 8. So if this were 532, it wouldn't work. 536, yes, it would work. Or if this were 428, it would not be divisible by 8. Again, check that video tutorial there. So 528 is divisible by 3 and 8, therefore it's divisible by 24. 25, very easy, think quarters, ends in 00, 25, 50, or 75. So 925, it ends in the 25, therefore it's divisible by 25. Then 28, you can check for divisibility by 4 and 7. So 812 would be a good example. Just look at the last two digits. 12 is, of course, divisible by 4. And then 7, well, you take 81, you break off the 2, you double the 2, that gives you 4. 81 minus 4 then is 77, which is a multiple of 7, 11 times. Now we have more complicated divisibility rules for some of these sort of awkward prime numbers and multiples of prime numbers. Now 16 is a power of 2, which is a real pain. We'll look at those as well. 27 also is a power of 3. Powers of 2 and powers of 3 are a little bit more difficult. And then, of course, we have all these other numbers, many of which are prime. So now we're going to go to 30 to 44. For 30, check for divisibility by 3 and 10. So it just has to end in a 0 and then otherwise be divisible by 3. So 690, 6 plus 9 plus 0 is 15. Multiple of 3, ends in a 0. Multiple of 10, therefore 690 is divisible by 30. For 33, divisible by 3 and 11. So 264, remember for 3 is just add up 2 plus 6 plus 4, which gives you 12. Multiple of 3, check. 11, 26, you break off the 4, and then subtract it from 26 is 22, which is a multiple of 11. So therefore your number is divisible, 264 is divisible by 33. For 35, look for 5 and 7. So it has to end in a 0 or 5, and has to be divisible by 7. So 385 ends in 5, so we're good there, check. 7, you break off 385 into 38 and 5, double the 5, that gives you 10, then you subtract that from 38. 38 minus 10 is 28, which is a multiple of 7. So therefore, 385 is divisible by 35. 36, you look for divisibility by 4 and 9. So 792, well, look at the last two digits for 4. 92 is 4 times 23, evenly divisible by 4, check. 7 plus 9 plus 2 gives you 18. That makes it divisible by 9. So therefore, 792 divisible by 36. Now for 40, what you can do here, obviously it has to end in a 0. What you can do is you can take off that 0 and then check the new number and just pretend that 0 doesn't exist. So for 360, for instance, you would just, it ends in 0, so it's possible because it's divisible by 10. But then if you take off the 0, you get 36, and 36 is, of course, a multiple of 4. So 360 would be divisible by 4. You could also use 5 and 8. It might be a little bit trickier, but that will work since 5 and 8's least common denominator is 40. And the LCD of 4 and 10, we're checking 10 and then 4, but this rule is void because we're creating a whole new number when we take off that 0. We're turning a 360 into 36, so that actually makes that whole rule of LCD that I showed you earlier void. So 40 is actually not that difficult. I'm just showing you a couple of different methods of figuring that one out. 42, look for divisibility by 6 and 7, or 2, 3, and 7. So 546. It's even, so it's divisible by 2. 5 plus 4 plus 6 is 15, so that's a multiple of 3, so it's divisible by 2 and 3, therefore it's divisible by 6. And then 54 and 6, remember you break it into 546 into 54 and 6, break off the ones digit, double it. 6 times 2 is 12. 54 minus 12 gives you 42, which is, of course, a multiple of 7. So 546 is divisible by 42. For 44, 4 and 11. So 968 seems like a stretch, but, well, 68 is divisible by 4. Look at the last two digits. Check. Is it a multiple of 11? Well, simply break 968 into 96 and 8, subtract the 8 from 96, and you get 88, which is a multiple of 11. 8 times 11. And for 31, 32, which is another power of 2, is 2 to the 5th power. 34, 37, 38, 49, 41, and 43. We have some divisibility rules to which we can derive. That's for a later lesson. Now we go 45 through 66. 45, you look for divisibility by 5 and 9. So it has to end in a 0 or 5, and then the digits of the number have to add up to a multiple of 9. So 8 plus 1 plus 0, of course, is 9. So, of course, it's divisible by 9. It's also divisible by 5 because it ends in a 0. So 810 is divisible by 45. 50, piece of cake, just has to end in 00 or 50. So 450 is divisible by 50. 55, you look at 5 and 11. So it has to end in 5 or 0. 275 does end in a 5, so check there. And then 275, you break into 27 and 5. Subtract the 5 from the 27, you get 22, which is a multiple of 11, so bingo. 275 is divisible by 55. 56, you can get that one from, it's not easy, but you can get that from 7 and 8. So 672, since this is even, we just look for divisibility by 8 here. And 72 is divisible evenly by 8. It's also divisible by 7. You take the 67, you break off the 2 and double the 2, which is 4, and then subtract that 4 from the 67, you get 63, which is a multiple of 7. It's 7 times 9. And for 60, it has to be divisible by 3, 4, and 5, or you could do 12 and 5, but 12 is 3 and 4. Another thing you can do is you can take off the 0 and then check for divisibility by 6. So obviously it would have to end in 0, and then, so 360, take off the 0 just like we did with 40, you get 36, and 36 is of course 6 times 6 or 6 squared. And again, just like in 40, since we created a new number, that LCD rule does not apply. So check for divisibility by 3, 4, and 5, and 360 was your example. For 63, remember our number 378 we used a couple times. Well, that's also divisible. Remember we said it was divisible by 7 and 9. Well, it's divisible by 9 because 3 plus 7 plus 8 is 18, which is a multiple of 9. 378, you break into 37 and 8. Double the 8, which gives you 16. 16 subtracted from 37 gives you 21, which is a multiple of 7. So 378 is divisible by 7 and 9, thus it's divisible by 63. For 66, you look at 6 and 11, or 2, 3, and 11. So for instance, 594. Well, it's obviously even, so it's divisible by 2. 5 plus 9 is 14, plus 4 is 18, so it's divisible by 3. And then if you take 594, break it up into 59, and break off the ones digit 4, subtract the 4 from 59, you get 55. Yes, that's a multiple of 11. So this number here, 594, is divisible by 66. And then 46, 47, all these other numbers, stay tuned for those. And finally, 70. through 100. 70, you look for divisibility by 7 and 10, so obviously it has to end in a 0. And then you look at the other digits. Now 91 minus 0 is just 91. A lot of people think 91 itself is a prime number, but it's not. It's 7 times 13. If you break that down, you just look at the number 91, break off the 1 from the 9 and double it, that's 2, and then 9 minus 2 is 7, which is of course a multiple of 7. So 910 would be an example of a number also divisible by 70. For 72, you look at divisibility by 8 and 9. So 864, this is even, so you can look at this and see if it's divisible by 8. 64 is, obviously. It's 8 times 8. And then look for divisibility by 9. These numbers add up to 18, so that's a multiple of 9. So yes, 864 is divisible by 72. For 75, it's pretty easy. Check for divisibility by 3 and 25. So 825, it ends in a 25, so it's divisible by 25. Then 8 plus 2 plus 5 gives you 15, which is a multiple of 3. So 825 is divisible by 75. For 77, you look for divisibility by 7 and 11. A little more complicated, but 616. So for 7, you would break off. You break off the 6 in both cases, but 616 you break into 61 and 6. For 7, you double the 6. That gives you 12, and 12 subtracted from 61 gives you 49. That's a multiple of 7. 7 squared, or 7 times 7. And for 11, you break off the 6 as well, but you don't double it. So 61 minus just 6 gives you 55, which is a multiple of 11. 5 times 11, so 77 goes into 616 evenly. For 80, you can take off the 0 and then check the remaining number for divisibility by 8. So 480, you slash the 0, and 48 is a multiple of 8, 6 times. So this would be 8 times, or 80 times 6. For 84, you look at 3, 4, and 7. So 756, it's divisible by 3 because 7 plus 5 plus 6 is 18, a multiple of 3. Divisible by 4 because 56 is divisible by 4. You look at the last 2 digits. And then finally, for 7, break the number into 75 and 6, double the 6, and subtract it from 75. So 75 minus double 6 is 75 minus 12. That gives you 63, which is a multiple of 7. So 756 is divisible by 84. For 88, you look for 8 and 11. So 528. Now, the 28 is divisible by 4, but not by 8. However, this is odd, so that actually makes it divisible by 8. And then 11, 52 minus 8 gives you 44, which is a multiple of 11. And then for 90, has to be divisible by 9 and 10. This one actually is pretty easy. So 720 has to end in a 0, obviously. And then 7 plus 2 is 9, so that's a multiple of 9, of course. So 720 is divisible by 90. And then for 99, you look for 9 and 11. So 1287, 1287. Well, you add those digits up and you get 18, multiple of 9. So check there. Now, this might not be obvious, but if you subtract 7 from 128, you get 121, which is a multiple of 11, 11 squared. If you don't see that right away, well, you would have 121 here, and then you would take the 121, you break it into 12 and 1. 12 minus 1 is 11. So either way, you can tell that 1287 is divisible by 11 as well. So therefore, it's divisible by 99. And then for 100, piece of cake has to end in 00. So 3,200 or 3,200 is divisible by 100. And then for all these other numbers, stay tuned. So up next, we're going to deal with those numbers that are powers of 2 and 3 and their multiples, such as 27, that's 3 cubed. 3 to the 3rd power. 32 happens to be 2 to the 5th power. 54 is twice 27, so 3 cubed in parentheses times 2. And then 64 is another one of those annoying powers of 2. It's great if you're playing, of course, like the NCAA tournament. That's 2 to the 6th power. So you have 6 rounds. Well, actually, you have to play in rounds, but we'll get to that another time. And then I'm going to show you a formula, a really cool formula to derive a divisibility rule for any number. Every number has a divisibility rule, believe it or not. This includes prime numbers, and note that any prime number above 10 will end in 1, 3, 7, or 9. If it ended in 5, well, it's divisible by 5, so it's not a prime number. And, of course, it can't be even because then it's divisible by 2. So thanks for watching. Hope that was informative, and stay tuned for some more tutorials.